means when a dipole is present in a uniform electric field, then what all phenomena can occur? So when the electric field is uniform and a dipole is present, then torque tries to align the dipole parallel to the electric field. This is what happens. And that will determine the direction of torque also. So we saw three cases when if angle is 0 degree, angle is 180 degree, and angle is 90 degree. So these were the three cases, and that's where we stopped. Now look, a little bit recap from your class 11th. You had a chapter waves and SHM, waves and oscillations. There it was mentioned that whenever you have the force directly proportional to the mean position and is directed towards the mean position, directly proportional to the displacement and directed towards the mean position. So the full formula was F is equal to minus Kx. So K was the spring factor constant. Similarly, when we talk about the same thing in rotational motion, it becomes tau is equal to minus K theta. So if any quantity is satisfying this condition in rotation and this condition in translation, we will say, what we will say? This is satisfying the condition of SHM. So this is how you have pendulum is present and the torque will try to bring the pendulum back to its mean position. So these are the conditions for SHM. So this is from your class 11 portion. That's why I'm not going into the details of it. But yes, how to calculate the angular frequency and the time period. The formula for angular frequency is under root K by I, where I is your moment of inertia. So whatever value of K you obtain from the above equation, put it here, you will get angular frequency. Time period is 2 pi by omega. So omega will be 2 pi by p. Now this was just a recap from class 11th. Mainly this is important and these things are important because it can be asked. So there's a question which says an electric dipole is placed in uniform electric field. Now when it is placed in uniform electric field, it is saying show that this is exhibiting SHM and then calculate its time period. Suppose this is the dipole plus Q minus Q, and this is making some angle theta with the electric field. This is the dipole. So, of course, torque will try to align it parallel to the electric field, and this will be parallel after some time, but the direction of torque will be in this manner. So, when we write, if we write about the restoring torque, restoring forces, whether it's the torque or the translational force, they are written with a negative sign. So here we can say torque is equal to minus PE sine theta. Now class, whenever you have small angle approximation, why are we focusing? Because see, how much will a dipole rotate with? Dipoles angles are very small with which they can rotate. Maximum is 90 degrees. So of course the angles are very small with which they are rotating. So we use here a small angle approximation. Small angle approximation means theta is less than or equal to 15 degrees. If theta is less than or equal to 15 degrees, you can say your sine theta or your tan theta, they are almost equal to theta. This is a condition. Small angle approximation. If your angle is less than or equal to 15 degrees, sine theta or tan theta will be equal to theta. So it means if this angle is following small angle approximation, then we can say torque is equal to minus PE theta. It means this is equivalent to the equation minus K theta. So look, from this equation, if I see the value of K, this is exactly the value of K which is replacing. So means the value of K is dipole moment into electric field. So yes, this is exhibiting SHM because from this you can easily see that yes, minus K theta is exerted. So yes, the system is in SHM. And the question said to calculate time period. So for time period, you need angular frequency. So look, angular frequency is under root K by I. So omega will be put the value of K as PE. Omega will be under root PE by I. So when you put it in the formula of time period, 2 pi by omega, time period becomes 2 pi under root I minus I by p. Because see, this is in the denominator. So PE will remain here and this root I will go up. So root I by p. This is the time period, what the question asked us to calculate. So this is the most difficult question that they can form in torque in your board exams part. Because it's a theoretical question and it relates with your SHM part. Okay. Have you understood, all of you?
Yes, ma'am.
Others, Jesleen, Shaima, Zainab.
Yes, ma'am.
Okay. Write it from that note part because that might be helpful when you're writing as a reference. Okay. Start writing from here and just update me in the chat column, then I'll scroll it. Jesleen, you didn't join yesterday?
Yes, ma'am. I was not feeling well.
Was there any exam or something, Jesleen?
No, ma'am, I couldn't join because I wasn't feeling well.
Okay.
Need to rest. Ma'am, can you scroll up? Done, ma'am. Ma'am, can you scroll up? Done, ma'am.
Class done?
Yes, ma'am.
No, ma'am.
Class completed?
Yes, ma'am.
Okay. See, class, what we were discussing till now was when the electric field was uniform. So dipole was placed in a uniform electric field, so we obtained that torque and everything. What if the dipole is put in a non-uniform electric field? Like this. Electric field is not uniform. It is even here. It is having some E2 value here. Now look, when we are calculating the net force over here, this will be QE1. This will be minus QE2. This won't get cancelled. And look, F net will not be equal to 0 this time. And torque was already not equal to 0. So net force is not 0 means the dipole will also translate. So this is how the dipole is when it is put in the non-uniform electric field. Because the net force is not getting cancelled. In the previous case, when we had the dipole, what happened? Why was it getting rotated? Because one force is being applied from this side. One force was getting applied from this side. Plus QE and minus QE. So this led to the rotation of it. Like this. If it is present, this led to the rotation of the dipole. Now, when we are talking about the dipole in non-uniform electric field, this time electric field is not uniform. So QE1 minus QE2 are not getting cancelled and are not giving you a 0 value. Means this is not a condition of equilibrium. No kind of equilibrium is achieved. At least in the uniform case, we had the dipole moving. It was at least rotating, right? This movement part was stopped because net force was 0. So translational equilibrium existed. But in this case, even translational equilibrium is not existing. Okay. Write this, then we'll practice one question and then we'll do next topic. Done?
Yes, ma'am.
Others also?
Yes, ma'am.
Okay. Let's just practice that one question which I was mentioning. See, this says that an electric dipole consists of two opposite charges of magnitude, means the magnitude of the charge is 1 by 3 into 10 to the power minus 7 coulomb, right? And they are separated by 2 centimeters. The dipole is placed in an external field of electric field is given as 3 into 10 to the power 7 Newton per coulomb. It is asking what is the maximum torque that the electric field exerts on the dipole. So class, can anyone tell me what is the angle here? Because it's not mentioned in the question. How will I solve it? Hmm? What do you think the angle should be?
Ma'am, 180? Oh, no, two opposite charges, yeah. Is it
No,
180?
no, no, no. See,
Mhm.
two opposite charges means that it is forming a set of dipole. Okay, so that's why two opposite charges. One
Oh, okay,
positive, one
okay.
negative. Okay. Think of the cases, the 3 cases we did. Just check the notes, then you will find it there.
0 degree.
No, then torque will be 0 straight away. Why 0 degree? Has it mentioned anything regarding 0? No? Check the cases, 3 cases that you people have written in the last class when we just ended the class before that. No one. What was the third case? Third one.
Dipole is perpendicular.
When dipoles were perpendicular. So what did we get? Sine 90 was 1. Maximum value of any angle, sine or cos, can be 1 only. And I made you write also that that is the maximum case. Maximum torque. If you remember, we did this. Look, I made you write also maximum. Torque is maximum when theta is 90 degree. That's why this has not given you the angle. Rather, it has mentioned just that this is maximum. That's it. It has just maximum, torque is maximum. This is what it has mentioned. It has just mentioned that torque is maximum. So theta is automatically 90 degree. Now when you calculate torque, torque is PE. That's it. Sine 90 is 1. So now when I have to put, so yes, Shaima, can you tell me what's the charge that I should write? For what is the dipole's value that I should get? Just tell me for dipole, Shaima. These are the values.
1 by 3 into 10 to the power minus 7 into 2 into 10 to the power minus 2.
Yes, very good. Dipole moment means, see, that's the separation between the dipoles. That is 2a is given as 2 centimeter, which is 2 into 10 to the power minus 2. So dipole moment is charge is 1 by 3 into 10 to the power minus 7. 2a is 2 into 10 to the power minus 2. And electric field, PE, 10 to the power 7. 3 gets cancelled. This gets cancelled. Torque becomes 2 into 10 to the power minus 2 Newton meter. Got it, class? This part. Write it down. Then we'll start with force on a charged particle in electric field. Those questions also come in the exam.
Ma'am, can you scroll up to the question? Done, ma'am.
Okay, others have also completed. Shaima and Ibrahim.
Yes, ma'am.
Okay. Then let's start with the force on the charged particle in electric field. Okay. That part is left and questions do come from this part. Now, see, when this I have discussed with you, but I told you, that we'll write it separately. Whenever the charge is positive, okay, the direction of force is exactly in the same direction as of that of electric field. But if you have a negative charge, like electrons, especially for electrons, just reverse the direction. You will get many questions for electrons. So direction of force will be opposite to that of electric field. Like, look at this question. This says a particle of charge plus 2 coulomb is in electric field 5 Newton per coulomb. You have to calculate the force. So force's formula, see, electric field is present, charge is present. What's the formula that connects it? Can anyone answer? Which formula should be suitable here? Charge is present, electric field is present, then no one. Yes, Zainab, try. Charge is there, electric field is present. How should I calculate the force?
F is QE.
F is QE, correct class. Yes, Shaima, she's right. F is equal to QE. Class, this is the basic formula of your electrostatics. If you'll forget this formula, then you'll not be able to manage with the tough questions. F is equal to QE. That is the formula. And I have been doing this in the torque part also. It's not that we have just done it in the electric field and we have stopped. I have done it in the torque part yesterday, means on Monday. So yes, the force will be 2 into 5. That is 10 Newton per coulomb, but the force will be along J cap because it's a positive charge. But when we are talking about negative charges, like if it is minus 2 coulomb of charge, so forces formula is F is equal to QE. So it will be 2 into 5, which is 10. Okay. But direction will be downwards, opposite to that of electric field, because this is a negative charge. So this will be minus J cap Newton per coulomb. Is this part clear to all of you?
Yes, sir.
Yes, ma'am.
Okay. Just write down this part from here. Charge particle in external electric field. Then we'll see how the questions come. 2 to 3 questions we'll do. And that kind of question only come in the exam. You just use your equation of motions. That we'll see. Done? Yes, class completed.
Yes, ma'am.
Okay. Let's start with the next part. That is the questions. How do questions come? So this is a very common question that comes. A proton and an electron are placed at rest near the positive and negative plates. Means the proton is here and the electron is here. Now, obviously, they'll get attracted towards the opposite plates. So it is saying calculate the time taken by the proton and electron to reach the opposite plates. Is D. Okay. They have started from rest and they are moving like this. Now we'll calculate first for one. Let's say for proton. For proton, we are calculating. Now class, distance that needs to be covered. Jesleen, can you tell me what's the distance that needs to be covered by the proton to reach the opposite plate? Yeah, Jesleen. If proton has to reach the opposite plate, what's the distance? Yes, Zainab, right. Jesleen, you don't know? Small d. Correct, Zainab. This is the distance that it has to cover. So distance for us is d. Ibrahim, can you tell me what's the initial velocity of proton?
What, ma'am?
Initial
Initial velocity will be 0, yeah?
Yes, right. Very good. Because it is at rest. So initial
Yes, ma'am.
velocity is
That yes, yeah.
yes. Now look, the rest of the things let us calculate. See, class, when we are talking about the force on the charged particle is actually Q into E. Now for proton, we know the charge is E and electric field is E. So when we are using acceleration is force by mass. Force is E into E by M. So for us, acceleration will be E by mass of proton, because I'm talking about proton right now. Now, I want to calculate the time period. Which equation of motion is suitable? If you look at all the variables that we have obtained. Out of all the three equations of motions, uniformly accelerated equation of motions, class 11th. These, by looking at these variables, which equation you think is a little appropriate? That will give you value of t. Yes, class 11th, equations answer.
Ma'am, what is the question?
Question you're asking, Zainab?
Yes, ma'am.
See, S is D, initial speed is 0, acceleration is EE by MP. We have to get the time period. That's what the question said. What's the time period for the proton to reach the opposite end? I am asking, among the uniformly accelerated equations, which of it is suitable, which we should apply? UT plus half AT square. Yes, Zainab, right. UT plus half AT square. So we have to use S is equal to UT plus half AT square. Now see, initial speed is 0. So this will be 0. So distance is D, half, acceleration is EE by mass of proton into T square. So what is T from here? Look class, time period will be 2mp into d divided by E into capital E under root. So this is the equation for the time period of the proton. Now for electron, I am not writing the entire thing again, but see, for electron, we'll perform the same steps. Same as the distance. Do you think in electron, or just tell me class, for electron, when electron reaches the opposite plate, what do you think should be the change in this? Or this should be exactly the same for electron also. Do you think any change in this formula? What we have got? Anything? Or this is the same answer it means?
E will become P.
E will become this electron.
P.
This will become P. You're saying, Shaima, this.
Yes.
Why? Charge on an electron is E only. Charge on an electron is E. Charge on the proton is also E. 1.6 into 10 to the power minus 19. So it will be the same. E will be the same. 2 will be the same. Check like this. What all things will be the same? What will be different? Yes, class, think. Which quantity will differ, will not be there in electron? Yes, Shaima, tell me. This is the formula for the time period of proton that we have got. In electron, what will be the change in this? Or this is exactly the same for electron also?
Mass will change.
Yes, mass. Now you're right. See, electronic charge is the same. E is the same. Electric field is also the same. It's moving in the same electric field. Distance covered by electron is also the same, d. 2 is already a constant. Mass of proton will not come. Mass of electron will come. This is the difference. And if a question comes to compare both of it, so look class, time is directly proportional to root of mass in this. Now you know mass of proton is greater than mass of electron. So time of proton will be greater than time of electron. Therefore, you can always say that electron will reach faster because its time period is less. Now, is it clear to all of you?
Yes, bro.
Write it. We'll practice one more question based on this. So these kinds of questions come in the exam, okay? Using your 11th class equations. Write it. Task completed? Done or still writing?
Done.
Done.
Done, ma'am.
All right, let's see one more question. Okay, this is just a question. See, in the previous year's question, I have seen this. So that's why I'm giving this is related to the force. So whenever you have this, this is actually how the charge on the electric field on the electron was discovered. Like that is 1.6 into 10 to the power minus 19. So Millikan oil drop experiment was an experiment through which it was conducted. So this kind of question I have seen it in the previous year, so that's why I included it. This says predict the magnitude and direction of electric field so that Q is in equilibrium. Q is a charge present with a mass m. So basically downwards you have the gravitational force. And if it is in equilibrium, the electrostatic force will be balancing it. It is there present in electric field. So QE will actually balance mg. So from here, magnitude of Q will be mg divided by E. That's it. This was one of the questions in your previous year's board examination. Okay, just write this quickly. Then we'll see one more question because this F is equal to QE. This is the force on the charged particle in electric field. This is what the whole formula is. So this was related to it. So that's why I've included it. This came in your 2 markers. Just write it and let me know done. Write done in the chat box. Then I'll get to know. Done.
Yes, ma'am.
Okay, let us see one more question. See, this says a particle Q enters a region of electric field with the velocity v. Length of the plate is given. Now see, this is the particle Q. It has not mentioned whether it's the electron present or it's the proton. So we will also take the charge as Q only. Speed is given this time v, means the initial velocity is not 0, it is given as v. And it is saying length of the plate is L. So calculate the deflection. First is time taken. So time taken we have practiced. We'll do this again. And second says deflection. This means, see, if a charged particle is present like this, what will happen? and this is moving straight. So will it move in a straight line? It's not possible because negative charge will attract it and positive charge will be repelling it. So like this, the charge will exit along the direction of the negative charge. So it is asking us to calculate this y separation. That is the deflection. Deflection means the separation. This is what the question says. So let's see the first part, class. See, for the first part, we will just check the x-axis. And second part requires y-axis. See, y is there, this deflection is along the y-axis, so we'll solve it along y. Because this is now in plane, and if you remember, whenever we did questions in motion in a plane, we solved everything along x and y-axis separately. So here also, see, if we solve motion along x-axis, length of the plate is L, force along the x-axis, okay, whatever force is acting along the x-axis will be 0 because acceleration is 0. Why? Acceleration is not present because the particle's movement is along y-axis. It is moving along the y-axis. So there is no acceleration along the x-axis. If there was any acceleration along the x-axis, it would have moved in a straight line. So acceleration is 0, force becomes 0. We need to calculate t. One more thing we know that initial velocity is equal to v. So see class, if you apply any of the equations, s is equal to, let's apply this only, s is equal to ut plus half at square. This part will be 0 this time. So L is equal to v into t. So first part says time period is equal to L by v, right? Yeah. This is the answer for the first part. Second part, for the deflection, let us calculate everything along y-axis. Because when you will calculate everything along y-axis, your displacement is basically along y-axis. So see, this time we will have the acceleration. Okay, when we are talking about the motion along the y-axis, we'll have the acceleration this time. And the acceleration will be as usual what we have decided before. And not E this time, it will be Q. So acceleration will be simply force divided by mass. Force of the charged particle, this is Q into E, and mass is m. So this is the acceleration that is present. Displacement along the y-axis is y only, which we have to calculate. There is no velocity along the initial velocity given along the y-axis, right? It was moving and it got deflected. So for us, the initial velocity will be 0. For time class, see, you can put this value from the time that you have calculated, which is L by B. So look, if we use the equation S is equal to ut plus half at square, again, this part will be 0. Y is equal to half. Acceleration is QE by M t square. So it will be L square by B square. So this will be the deflection. Got it, class? Both the parts. Did you understand?
Yes, ma'am.
And what about other students? Jesleen, Shaima, Zainab, do you want me to repeat anything? Anything you've not understood?
Yes, ma'am.
Okay, write down this question then. Jesleen, you've understood? Jesleen, you there? Okay, Jesleen. Class done? Written till here?
Yes,
All of you?
ma'am.
Yes, ma'am.
Okay. So see, now there's a theoretical part, which is electric field lines. So basically, when you have electric field present, so electric field is present around the charged particle, and it's the property of a single charge, right? This is what we have studied. When a single charge particle is present around that, the field exists, which is electric field. Now, how are we going to represent that electric field? If you want to explain me, or if you want to explain it to someone, you cannot draw the electric field every time, because it's just a property that can be felt when you bring up a test charge. That's why we brought the test charge, so that we could assess whether the electric field was existing around the source charge or not. So electric field lines are basically geometrical and pictorial representations of electric field. They will help in representing whether we have electric fields existing or not, or if they are existing, then how should we mark them. So definition, see, electric field lines are geometrical and pictorial representations of electric field. They are continuous curves. And how to get the electric field then? Okay, if electric field lines are lines which are representing electric field, how will we get the electric field? So just drop a tangential that will give you the electric field like this. Look, like this, you will get a tangent. You drop up a tangent that will give you the electric field. So in your exam, only the properties from electric field lines come. If a question has to be there, it will ask you define the properties of, or write the properties of electric field lines. So you just need to mention whatever properties are there. Or from one or two properties, it can give you figure. The question can give you a random figure with a charge, and it will ask you to identify which property has been used, or it can even ask you in your MCQs, different figures will be given, and it can be asked which of the above is incorrect. So a wrong figure will be there amongst them. So that's how the questions are there from electric field. And it's a very easy topic, a theoretical topic. Just remember its definition and the properties. That's it, it's done. After this, we have a good topic to discuss, that is your electric flux and Gauss theorem, which will end the first chapter. But let us see this. What are the properties of electric field lines? First property, as I discussed, tangent to electric field lines give the direction of electric field line. So, yes, all those who were there in 11th, Shaima, Zainab, Jesleen, you remember we did a concept in hydrodynamics where I told you two streamlines cannot intersect. Remember, are you able to recall? We did streamline flow, turbulent flow, laminar flow.
Yes, ma'am.
So that time we discussed that two streamlines cannot exist because at a point there will be two directions. Same thing is here. See, tangent to a point gives electric field. So if two electric field lines are intersecting like this, what will happen? At this point, like this is the point A, at this point, it will give a direction of electric field, and the same point will give a second direction of electric field. A single electric field cannot have two directions, and a single point is having the two directions of electric field, which is physically impossible. So that's why electric field lines do not cross each other. Right? So that's why this is what I think has been written. Two electric field lines can never cross each other. At the point of intersection, two tangents can be drawn. So that is physically impossible, which will mean that two direction of electric field lines exist. Two separate electric field lines are acting from separate charges. That is possible. But at the same point, both the electric field lines are acting. That is not possible. So that's why we have this as our first property. Okay, second property says that, see, wherever electric field lines are written close to each other, it means their strength is stronger. Like if I have this means the value is greater. And if they are located at a distance like this, they are far away from each other, it means strength is weak. Strength of electric field is weak. Electric field lines are basically representing the electric field. So this is showing that electric field is weak. So if I have this region, I will say here the value of electric field will be stronger. So wherever you find the lines written together close, it means they have the value of the electric field greater. 8 coulomb or 5 coulomb. 8 coulomb will have all the lines together. 5 coulomb will have the lines at a little separation. Are those two properties clear to all of you?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay, so just write it. Much time is not left. Quickly write it. Rest of the properties and electric flux I'll discuss on Monday. And C class, 2 assignments now. One will be from the topic torque that is already given to all of you on Mondays from Monday's class. And second is this force on the charge particle that we did today. 3 questions I have given from this that you will receive. So these 2 assignments I'll discuss on Monday, and please attempt the test paper. I think this time Ibrahim also has to attend.
No, ma'am. I gave my test today. Yeah, I gave my
Okay,
test
you have
today.
given Ibrahim.
Yes, ma'am. A few hours ago only I gave. Before this class, I finished. Yeah.
Okay, all right.
An hour before starting, I finished the test.
Okay, okay, great then Ibrahim. I'll discuss the paper on Monday then.
Okay, ma'am. Okay.
Jesleen, you also attempted. Zainab, you told me that this one you will not be able to do. Right. What about you, Shaima? Or
Yes, ma'am.
will you be able to attempt it any of the days before Monday?
Ma'am, this test.
The weekly test?
I'll see on Saturday if I can.
Okay, try it on Saturday if you can. And Zainab, you also try if it's possible on Saturday or Friday night, something. Okay, Zainab, you also just try.
I'll do on Friday.
Okay,
Oh,
okay.
Saturday. Sorry.
All right, all right. And Zainab also Saturday. Okay. Yeah, okay. You people give it on Saturday. I'll check it on Sunday, and on Monday we'll have the discussion. Okay, class, you have written till the first property. This one, all of you have written.
Yes.
Yes, ma'am.
Yes, ma'am.
Okay, from the second property, I'll show you it in the next class. Your time is